Hello, space explorers. Welcome back to the channel. Today, we're embarking on a journey to uncover the fascinating history, enduring mysteries, and thrilling future of our very own moon. Get ready to have your perspective shifted. Look up tonight. There it is, our constant companion in the sky, the moon. For millennia, it has captivated us, inspired us, and puzzled us. It's more than just a big rock orbiting Earth. It's a cosmic history book, a scientific enigma, and humanity's next great frontier. So, where did our moon come from? The most widely accepted theory is as dramatic as it gets: the giant impact hypothesis. Imagine billions of years ago, a Mars-sized protoplanet, nicknamed Theia, slammed into the young Earth. This wasn't a gentle nudge. It was an apocalyptic collision, ripping material from both bodies, which then coalesced in orbit to form what we now know as the moon. Talk about a fiery start. This violent birth explains many things: the moon's relatively large size compared to Earth, its lack of a significant iron core, and the similar isotopic composition of lunar and Earth rocks. For hundreds of millions of years after, the moon was battered by asteroids and comets, forming the craters we see today. This period is known as the Late Heavy Bombardment. For millennia before we understood its origins, the moon was a source of profound mystery. Cultures worldwide wove elaborate myths around it. Some saw a deity, others a guiding light, a calendar, or even a giant cheese. But as science progressed, the myths began to recede, replaced by new, more tangible mysteries. Why does the moon always show us the same face? This is known as tidal locking, a fascinating consequence of gravitational interaction between Earth and moon over billions of years. And what about water? For a long time, the moon was thought to be bone dry, but recent discoveries have completely overturned this idea. Missions like India's Chandrayaan-1 and NASA's Lacrosse impactor confirmed the presence of water ice in permanently shadowed craters at the lunar poles. This isn't just scientifically thrilling. It has massive implications for future exploration. The mid-20th century ignited humanity's greatest space race, the desperate quest to reach the moon. The Cold War spurred both the United States and the Soviet Union to unprecedented technological achievements. The Soviets fired the first shots, with Luna 2 becoming the first spacecraft to impact the moon in 1959. They achieved many firsts: first farside photos, first soft landing, first lunar orbit. But it was the Americans, with the Apollo program, who delivered the ultimate prize. On July 20th, 1969, Neil Armstrong uttered those immortal words as he stepped onto the lunar surface. "That's one small step for a man, one giant leap for mankind." 6 Apollo missions landed a total of 12 astronauts on the moon, bringing back over 382 kilograms of lunar rocks and soil. These samples revolutionized our understanding of the moon's geology, age, and formation, confirming the giant impact hypothesis. It was an era of unparalleled scientific discovery and human courage. After the Apollo era, lunar exploration quieted down for a few decades. But in the 21st century, a new lunar renaissance is well underway, driven by both scientific curiosity and ambitious long-term goals. Nations like China, India, and Japan have launched successful robotic missions, mapping the surface in unprecedented detail and making new discoveries. China's Chang'e 4 even achieved the first-ever soft landing on the moon's far side. And now, NASA's Artemis program aims to return humans to the moon by the mid-2020s. And this time, it's different. It's not just about flags and footprints. Artemis seeks to establish a sustainable human presence on the moon, utilizing lunar resources like that newly discovered water ice. Imagine a lunar gateway space station, permanent lunar bases, and even resource extraction operations. The moon could become a stepping stone for missions to Mars and beyond, a proving ground for new technologies, and a vital outpost for scientific research. Despite all we've learned, the moon still holds secrets. What caused the striking differences between the moon's near and far sides? How did its internal structure evolve? And could there be microorganisms deep within its rocks, surviving since the early solar system? The moon represents not just our past, but our future. It's a reminder of humanity's insatiable drive to explore, to understand, and to push the boundaries of what's possible. The next few decades will be pivotal for lunar exploration. We're on the cusp of an incredible new era, where the moon transforms from a distant light in the sky to a thriving outpost for humanity. So, the next time you look up at the moon, remember its incredible journey, from a violent birth to a silent witness of Earth's history, and now to a beacon of our future in space. What excites you most about the future of lunar exploration? Let us know in the comments below. If you enjoyed this cosmic journey, please give us a like, share this video with your fellow space enthusiasts, and subscribe to the channel for more fascinating insights into the universe. Thanks for watching, and keep looking up. The universe is waiting to be explored.